Hi friends, and a very warm welcome to all of you. I, Harsha ma'am, welcome you in this e-learning session. Do you remember which lesson we are doing? We are doing chapter number 2, that is force and laws of motion. For your kind information, we have completed the theory also. The numericals are on the last stage. Okay, it's not like Corona, the various stages, but still there are some levels by which we go. So, for your kind information, we have almost completed all the types of numericals, and today we are going to do the numericals which are based on law of conservation of momentum. After that, we'll take just one session of higher level questions, that is think outside the box question, and we will wind up with the numericals. And we'll start with the next further chapter. So what was the law of conservation of momentum? I hope that you remember, because in the last session I made you recall about this particular concept. Okay, what was the concept? Do you remember? There are two objects having their individual masses and they are moving with the different speeds. That is their initial velocities. Because of some reason, they collide with each other and they exchange some kind of forces. This is on the basis of Newton's third law of motion. Now, on the basis of the Newton's third law of motion and law of conservation of momentum, as well as by using the Newton's second law of motion, we concluded that initial momentum of the object is equal to the final momentum of the object, that is momentum before collision, will be equal to the momentum after collision. This was all about what we had considered and what we had studied in our previous sessions. Now in today's lecture, we are going to move further and we are going to study about the next particular chapter. Which is the next particular chapter we are doing? Which is the next particular session that we are doing? This law of conservation of momentum. Let's have a look at the very first question. We are doing numericals. A body of mass 2 kg initially moving with the velocity of 10 meter per second collides with another body of mass 5 kilogram initially at rest. After collision, velocity of first body becomes 1 meter per second. Calculate the velocity of the second body. So, what is the question given to us? First, we'll try to understand that. They are talking about two bodies. Whenever we will be discussing about the law of conservation of momentum, we are knowing that we are going to deal with two bodies. So, there are two bodies and the body of mass 2 kilogram. So, first, let the first body be M1. We will write the given data over here. mass is 2 kg, so m1 is equals to 2 kilogram. It is moving with the velocity of 10 meter per second, so initial velocity is 10 meter per second. It collides with another body of mass 5 kg. So there is another body, m2, which is of 5 kilogram, initially at rest. So its initial velocity u2 is 0. After collision, velocity of the first body becomes 1 meter per second. So we have v1 as 1 meter per second, and they have asked about v2. This is what is given to you. After this, you just have to put the values and solve the numerical. Okay? Be quick. What is the formula? As per law of conservation of momentum, what do we have? We have m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Correct? Now just put the values. m1 is 2 kg, u1 is 10, m2 is 5, u2 is 0. Again m1, which is 2, v1, which is given to us as 1 meter per second, plus m2, which is 5 kg, and v2, that is the velocity that we have to find out. Okay. Now what is 10 twos are? 20 plus 5 zeros are 0 is equal to 2 ones are 2 plus 5v. Now what you have to do? Here 20 plus 0 is 20. This 2 will come over here. So 2 will get subtracted. So what is 20 minus 2? It is 18 is equals to 5v. Right? 18 is equals to 5v. So 18 upon 5 is equals to v, which means v is, when you divide 5 by 18, you get 3.6 meter per second. This is what you get the final value. If we consider the sign over here, then basically it will be negative in the sign because of the fact that when they are colliding, if one is at rest, then its velocity will change, and hence here the negative sign will come. So, although we have considered positive, but it is acting in which direction? Opposite direction. That you have to understand in your brain. Okay? Be quick. Note it down. I am giving you 2 minutes to note it. This is the first question of the day. Okay, exactly 2 minutes ma'am is giving you. For kind information, we have done many such sums which are not there in the textbook. So it's compulsory for you to note down all the questions, because ma'am will be doing only some questions in which all the concepts are coming. So kindly be quick. Last 1 minute for you to note it. Be quick and note it. I hope that you have noted now. We'll move further with the next particular question. If not noted, then take the screenshot. I'm giving you 5 seconds. 5, 4, 3, 2, 1. Let's move. Next is how much momentum will the object of mass (10 kilogram) transfer to the floor if it falls from a height of 5 meters. Consider the object falling freely and take acceleration as 10 meters per second square. Now, read the question. How much momentum? So they have asked you, what is the momentum? Will the object of mass 10 kilograms? So mass is given to us as 10 kilogram. It will transfer to the floor if it falls from the height of 5 meter. So height is given to us as 5 meter. It is initially falling. It's a free fall. Whenever you are having the words like free fall or initial rest, stationary, at that time you have to take the velocity as 0. So here it is said that object is falling freely. Whenever it is a free fall, you have to consider the initial velocity as 0. When we will be doing chapter number 3, at that time I will explain you the free fall concept. One whole lecture will be taken on this word free fall. Imagine how much importance this word is having. One whole lecture. So just think, so initially u, that is 0 meter per second. And it is, they have asked that what will be the momentum that it is transferring to the floor. And you have to take the acceleration as the gravitational acceleration, which is 10 meter per second square. This is what they have said to us. Now we want the momentum. For momentum, we want the velocity with which it is falling. In order to find the velocity of it, just think about what concepts we are having. When the object will be falling, if it is covering a height h, then this height will be equal to its displacement. Initially it was over here, then it came over here, then this became its displacement. So here h will be equal to s. You have s, you have u, you have a, you want v. Which is the formula that is applicable over here. Is anything coming into your brain just now? If it's not coming, then it's very bad. If it's coming, then it's very good. As per the equation of motion, here chapter 1 enters. As per the equations of motion, you have v square minus u square is equals to 2as. V square I want to find out. U square is 0 square. 2 into acceleration is 10. What is the displacement? It's 5. So v square is equals to 5 to the 10 into 10, which is 100. So what is the velocity equal to? Under root 100, which is 10 meter per second. The velocity of the object, final velocity of the object is what? It's 10 meter per second. Now coming to momentum. What is the momentum of the object? Denoted by P. It is equal to the product of mass and velocity. Now what is the mass? It's 10 kg. What is the velocity? It's again 10 over here. What is 10 tens are? 100 kilogram meter per second. Why? Because this is the momentum. Okay? Is it clear? Okay? So this is how you can calculate the momentum. Here the entry of chapter number 1 came. So only ma'am is saying that whenever the previous concepts are there, you have to revise. Be quick, note it fast. You have exactly 1 minute to note it. After you note, we'll move further with the next particular question. Be quick. Be quick in noting the content. I hope that you have noted. So now let's move further with the next particular numerical. A bullet. This is the bullet that is coming out from the gun, okay? Not that bullet that people are riding. A bullet of mass 20 gram is fired from a pistol of mass 2 kilogram with the horizontal velocity of 150 meter per second. Calculate the recoil velocity of piston. That is, in this case, what was the formula that we had considered? We had considered this. That is, velocity of bullet into velocity of bullet is equal to mass of gun or pistol into the velocity of pistol. Okay, do you remember we had done this? But before we put the values, let's consider them. Let's check out whether they are in SI unit or not. Mass is 20 gram for bullet. So MB, mass of bullet, 20 gram, which is 20 upon 1000. Next, it is fired from the pistol of mass 2 kg. So mass of pistol, or you can write gun, it's 2 kg. Bullet is moving with the velocity of 150 meter per second. So V into B is 150 meter per second. Next, what they have said is calculate the recoil velocity of pistol. That means what is the velocity Vp of the pistol? Put the values over here. I think the question is clear. The mass of the bullet is 20 grams, so 20 upon 1000 into the velocity of the bullet, which is 150. That is equals to the mass of the pistol, which is 2 kg, into the velocity of the pistol, recoil velocity. Now, the basic calculations only needs to be done. 0, 0 cancel, 0, 0 cancel. This 2 and this 2 will get cancelled. So 15 by 10, which is 1.5 meter per second. And that is the recoil velocity of pistol. Be quick and note it down. Okay, I hope that you have understood. Concept is very simple and very easy one. So be quick. Once we complete with this, we'll do the next numerical. You have exactly 1 minute to note it. Be quick. To note the content. I hope that you have noted this particular content. So I'm giving you last 5 seconds. If not noted, be quick, then we'll move with the next numerical. So next numerical, question number 4. The question is, a bullet of mass 200 gram, this is a new one, okay? And we'll solve one more such numerical. which will be non-textual. A bullet of mass 200 gram moves with velocity of 200 meter per second and gets embedded into a stationary wooden block of mass 980 gram. With what velocity will the block move? Now this is the question where most of the students do mistake. And which type of mistakes they do, that also I'll discuss with you. Most of the students over here apply this concept. That is, mass of bullet into velocity of bullet is equals to mass of the block into velocity of the block. And then they solve it. And then they become happy by solving it once they get the answer. But no, this is a wrong concept. Basically, most of the times you have to understand about where to apply which concept. By reading this, you should come to know that over here, the things are different than what was discussed about the bullet and the pistol. Here the concepts are changing. Try to think and try to analyze the question, and as in how I had said you that you have to try to do the numerical in the way what I say, that is, first convert it into mother tongue, then try to solve it. It will definitely help you out. Okay, so be quick. A bullet of mass 200 gram. So we are having the mass of bullet, there is a bullet, and its mass is 200 gram. We need to convert it into kilogram, so 200 divided by 1000. It moves with the velocity of 200 meter per second. So this is going on. So velocity of the bullet, that is also 200. It gets embedded into a stationary block. So here you are having one particular concept where the bullet is fired, this block is stationary, and the block is having the mass of 980 grams. So mass of the wooden block is 980 grams. Convert it into SI unit, 980 by 1000. Okay, this is the initial velocity of the bullet, that is UB. Initially the block is at rest. So initial velocity of the block will be 0. Next is, read the question again. Bullet of mass 200 gram is moving with the velocity of 200 meter per second and it gets embedded. Means once this bullet hits into this particular block, bullet and block both will move. You might have seen in many particular movies, whenever the firing is done and the bullet moves, then if it is embedded on any particular object, then that object will also move with the velocity of the bullet. So what happens? Initially it was at rest. Once the bullet enters into the block, once it entered, this will also start moving. Once it will start moving, what will happen? The final velocity of the bullet will be equal to the final velocity of the wooden block, and that is, suppose, say V. Because once the bullet gets embedded into the block, both will move with same velocities. Right or wrong? Understood? That's the only concept over here. Most of the times, whatever we got about the recoil velocities and that, in that and over here, the concept is different. Their initial momentum was 0. Here initial momentum is not 0. It is having its initial sum of momentum. So here you have to apply the concept. This is a key factor over here. Okay, do not forget to mention it. Now as per the law of conservation of momentum, what do you have? You have initial momentum is equal to final momentum. What is the initial momentum now? Initial momentum is MBUB, mass of the bullet into velocity of the bullet, plus mass of the wooden block into velocity of the wooden block. That is U, initial velocity of the wooden block. First all the initial and then all the finals. Final momentum is mass of the bullet into final velocity of the bullet, and we know that final velocity of the bullet as well as the wooden block is same, and let it be V. The final momentum is V plus mass of the wooden block into V, because both these values are same. Now we just need to put the values. What is the mass of the bullet? 200 gram. Initial velocity of the bullet is 200 plus initial velocity of the block, stationary block. So it is 0 because 0 into anything will be 0. Here V is common. Velocity of the block as well as the bullet is common. What is the mass of the bullet? It's 200 gram plus mass of the block is 9. It's 980 gram. Okay? Is it clear? Now let's move further. What will happen? 0, 0, 0, 0 cancelled out. Okay? One more 0 got cancelled out over here. So what is 20 into 2? It is 22s are 40. Right? What is 22s are? It's 40 is equal to. Over here the velocities are 980 upon 1000 and 200 upon 1000. So here we need to solve it by LCM. So how can we take the LCM? 200 plus 980 is what? It's 1180 upon 1000. Just add 9 plus 2 is 11, and at the behind you are having the zeros. So what happens into V? So what is the V equal to? It's 40 into 1000 upon 1180. Okay? Once you solve it, you will get the answer as 33.89 meter per second. This is the velocity with which it moves. Now in your textbook, instead of 200 gram, it's 20 gram. Okay. And I did the sum which is not there in the textbook. Intentionally, instead of 20 gram, I have taken 200 gram. If we take over here 20 gram, things becomes more and more simplified. But I I did it by taking one more 0 so that you come to know about how the calculations are getting done. Now this, I am giving you just 2 minutes to copy this because this question is not there in your book. The values are different. Yes, the concepts are same. And I am going to give you one more question today, right now to solve. Be quick, note this. You are having exactly 1 minute to note it. And be quick in noting. Same concept again. But I'll change the values in front of you and I'll solve it. Concepts will remain same, bete. Be quick and note it. Once you have understood this, your textbook sum will become very easy for you because in it the calculations are very easy. If you have not noted, then take the screenshot. I'll do your textbook numerical and one more numerical I'll give you. Okay? So, I hope you have noted. In your textbook, instead of 200, 20 is given. So, if 20 is given, things will become more easy for you. 20 upon 1000, the calculations now become easy. There is 1 0 less, so this 0 will also get cancelled out over here. So what will remain is just 4. Over here you have 1000 upon 1000, which will become 1. So the final velocity will become 4 meter per second. This is your textual numerical, where I took 200 gram intentionally just to show you how the results are varying and how to do the LCM. Especially for that I did it. So 20 grams, so the answer comes to 4 meter per second. Just 1 0 was less and things become so easy. Okay? Take the screenshot of this. I am out of your screen. No need to note it. 5, 4, 3, 2, 1. Now next. One more numerical. A bullet of mass 2 kg. That is, instead of bullet, let's take an object of mass 2 kilogram is moving with a horizontal velocity of 9 meter per second. It gets struck with a stationary block and the of mass. Now the mass of the block is 4 kilogram. With what velocity both of them will move. That's the next question. It's like this only. The one we did of bullet. Okay? Concept is same. Initial momentum is equal to final momentum. Quick. There is an object of mass 2 kg. So, we are talking about M1 as 2 kilogram. It is going with a velocity of 9 meter per second. So, U1 is 9 meter per second. It gets embedded, it strikes, okay, and it strikes with a stationary wooden block. So, mass of the wooden block is 4 kg, and initially it was at rest. And both of them together afterwards they will move. So the V1 is equals to V2 is equals to V. The concept that we did before this particular sum. Okay? How it gets embedded, the concept. The same concept you have to apply over here. That is this. Initial momentum is equals to final momentum. Because I am doing this similar sum, I am a bit quick. And you have to be quick with me. M1U1 plus M2U2 is equals to M1V1 plus M2V2. Now what is M1U1? 9 into 2, that is 18, plus U2 is 0, so this will be 0. M1 into V1, that is 2V, plus M2 into V2, which is 4V. Now what is 4 plus 2? 6. So 18 is equals to 6V, which says V as 18 by 6. That is 3 meter per second. Every time you will have like this only. The questions will change, only the digits will change, the concepts will remain the same. Okay? I am giving you 30 seconds to note it down or to take the screenshot, whatever you feel like. Then the last words and will depart. Be quick enough. Okay? Here your 30 seconds in. So I hope you have understood the concept. Concepts are more important. In our next lecture, we are going to do higher level of sums of this particular chapter only, and then we'll conclude with this lesson. I hope that you have understood all the concepts of the lesson. Yet if any doubt, you can contact me or call me on my number which you already have. So that's all for the content of the day. Thank you so much for listening to me and have a very good day all of you. Bye-bye.